Well, hello, good morning, good afternoon, good evening, wherever you are in the world, and welcome to this Autodesk Manufacturing webinar. My name is Clinton Perry, and it is my pleasure to be your host today as we take a look at the latest release of Autodesk PowerMill, that being PowerMill 2022.1. Now, before we get going, I'd just like to quickly display Autodesk's standard safe harbor statement. And while today's presentation is pretty much going to focus exclusively on functionality that will be included in this particular release, I will be talking about preview functionality, and that represents ongoing development work that could be included in future releases. Now, where possible, I'm going to remind you of that fact, but please note that things can change. Software development is an agile process, features can be delayed and possibly indefinitely, and you should take that into account when making your purchasing decisions. Now, with all of that said, let's continue by looking at some of the highlights of this latest release of PowerMill. Now, PowerMill 2022.1 will be released starting the 8th of November 2021. And as with previous releases, eligible customers with an active subscription will be able to access the update through their Autodesk account starting on this date, the 8th of November, or shortly thereafter. And we're going to go into a little bit more detail about how you can download this version later on in this presentation, so stick around for more advice. Now, continuing the theme of recent releases of PowerMill, this release includes a mixture of fixes, improvements, and new functionality, all designed to improve PowerMill's performance in terms of speed, quality, and reliability. So let's dig into it and take a look at some of the major highlights in this particular release. Now, I've picked out 6 of my personal favorites. There are more, we're going to cover more of them later, but these are what I think to be the 6 most impactful improvements for you, our PowerMill users. The first is the ability to carry out NC program and toolpath verification commands as background processes. The second is the option to control projection ranges when creating projection finishing toolpaths. Third is some improvements that we put in to speed up the time taken to load the toolpath settings form. Still on the subject speed, we have improved model preparation, which will have a positive impact on many areas of PowerMill's toolpath creation commands. Next is some small but significant improvements we put into PowerMill's toolpath limiting functionality. And then finally, I'm really excited to show you an early preview of a completely new rest finishing strategy that we're looking to release in a future version of PowerMill. And this is preview functionality, so remember that safe harbor statement I mentioned before. So let's take a deeper dive into each of these 6 features, and then we'll look on some of the more broader functionality improvements later on. So first of all, let's look at background NC program and toolpath verification. Now, for quite some time, PowerMill has provided the ability for you to queue certain commands. So if you're calculating a toolpath, you can either calculate it in the foreground, in which case all of PowerMill's processing power is consumed, meaning you can do nothing else. Or alternatively, you can send the calculation to a background process, which means that whilst that process is running, you are able to continue to interact with PowerMill and create more CAM programming tasks. We've extended this concept of background processing in this release to include NC program and toolpath verification. So this is the ability to check NC programs and toolpaths for things like collisions, gouges, exceeding machine tool axis travel limits, and so on. Now, by queuing this process to the background, PowerMill remains active. So there's still PC resources available, allowing you to continue with other CAM programming tasks. Whereas in previous versions of PowerMill, the verification could only be carried out in the foreground, meaning that PowerMill would be sat there consuming 100% of your PC's resources, meaning you could do nothing else with PowerMill. And that would be a big waste of your time. So the potential impact here is clear and huge, as you can now verify toolpaths and NC programs in the background and continue with other activities. So that's an obvious benefit. But I did want to dwell on maybe a less obvious one, and that is that by making verification a background process, it is more likely that you will actually run verifications at all. I can imagine situations where the additional time to wait for a verification to complete might make it very tempting for you to say, let's not verify. And you can imagine the consequences here could be quite bad. You may end up having collisions on your machines. So by making verification a background process, we believe you're more likely to use it, which will increase your confidence that your NC programs and toolpaths are safe and efficient for you to run on your machines. Moving on, the next thing I'd like to talk about is some improvements we've made to our projection finishing toolpaths. Now, the previous release of PowerMill, that's 2022.0, included new user interface options that allow you to manually define and control projection range limits for curve and surface projection finishing toolpaths. This latest release extends these options to apply to line, point, and plane finishing projection toolpaths too. Now, the use of projection ranges provides more programming control and can help you create toolpaths that machine only the areas that you want to, whilst avoiding over machining any other surrounding or shielding geometry. And the images that you can see on the right hand side of the screen here really show this beautifully. The image in the top right corner shows the machining of a cylindrical feature on a larger automotive component. We've used line projection finishing here, and because projection finishing works from the outside of the model inwards, unfortunately, you can see that there are areas of surrounding geometry that have been included in the toolpath. That's not correct. We don't want the toolpath to machine those features. By using manual range projection limits, we're now able to limit the toolpath just to work in the area of interest, meaning we create the right toolpath, avoiding the need for any additional toolpath editing or limiting or even alternative strategies. This means we get the right toolpath first time, allowing us to reduce CAM programming time and produce your parts sooner. The next thing I'd like to talk about is some improvements that we've made to PowerMill's toolpath settings form. Now, this is one of the most commonly accessed parts of PowerMill's interface. And what we've noticed is that this form has got slower over the last few years. And that's for good reason. The form contains more data, more settings, more information, and so it has become bigger and therefore has taken progressively longer for the form to open. But based on customer feedback, we realized that the time had come to make this form faster. Now, in our tests, we believe that the toolpath settings form is now typically 65% faster than previous releases. But we have had experiences with beta customers that have reported even bigger time savings. And one I wanted to point out was from one of our large automotive customers in the Far East, who complained justifiably that their large projects, so in this case it's 5.7 gigabytes with lots of stock models and toolpaths, this part resulted in a form load time of 12 seconds. Understandably, they were not happy with this, but they hopefully will be happy that in this latest release, typical load times for them have reduced to less than a second. That's a 90% time saving. Now, you access this form not only to create a toolpath, but to recalculate a toolpath. So all it takes is for you to access that form 100 times a day, and based on these numbers, you'll be saving yourself 18 minutes of CAM programming time. So obviously the impact here on you is improved user experience, faster CAM programming, you're saving time. Now, I'd want to show you a side-by-side video that shows this in action on a different data set. And the PC that we've used to carry out these tests is shown on screen now. It's a Lenovo ThinkPad P71 laptop with quad-core Intel chips, 64 gig of RAM, and an NVIDIA Quadro graphics card. So a reasonable spec PC, certainly not the best that you can buy on the market today. Okay, so this slide shows two versions of PowerMill running side by side. PowerMill 2021.0 on the left and PowerMill 2022.1, the latest release, running on the right. Now we're going to watch this video again in a second because it happens quite quickly, but what's clear to see is that the toolpath settings form is faster on the latest release. Now I'm going to play this video again, and I want you to pay attention to the PowerMill 2022.1 that you can see on the right hand side of the screen. Notice that In the latest release, the toolpath settings form has appeared. We click Calculate. The toolpath calculates, the form is closed, the command is complete. And all of that happens in less time than it took PowerMill 2021.0 just to open the form. So on this data set, on this particular PC, you can see some significant time savings to be had, and the cumulative effect over a shift or a day or a week could be huge. Now, we've repeated these tests still on the same Lenovo PC, but on different data sets with different toolpath forms, and you can see a snapshot of all of those test results here. So we're comparing again PowerMill 2021.0 with PowerMill 2022.1 across model rest area clearance, raster finishing, constant Z finishing, and turn roughing, and we can see typical time savings of between 47 and 65%. So these are huge time savings, and don't forget, you might see even more, such as our automotive customer in our beta program who reported 90% time savings. Now, I just want to change tack slightly and still on the subject of speed, talk about improvements that we've made to PowerMill's model preparation. Now, you might be wondering, what is model preparation? It's an integral part of many toolpath-related processes. So if you've ever watched the progress bar at the bottom of PowerMill's main display when you've been calculating a toolpath, you may have seen text appearing that states scanning model or preparing model. Now, this is one small part of the overall algorithm or process that we go through in order to complete that task. And we've realized that this is an area where we could get improvements in terms of speed. And so PowerMill 2022.1 has had significant effort put in to speed up that model preparation. But how does that impact you and your daily experience of PowerMill? Well, model preparation is an integral part of processes like toolpath calculation, toolpath editing, and even if you edit a toolpath's leads and links, meaning this improvement should affect all of those common tasks. And in our tests, we've seen the biggest gains happen when editing toolpaths, specifically if editing toolpaths that machine large parts or if toolpaths use very small tolerances. And in our tests using actual customer data from one of our largest automotive customers in the Far East, we've seen model preparation times reduce from 48 seconds in the previous release of PowerMill to 18 seconds in this latest release. That's a saving of 30 seconds or 62%. So the obvious impact here is time, saving you time so that you can start your CNC machining tasks sooner. Now, the video on screen compares the time taken to edit a corner finishing toolpath using polygon sketched limiting. As before, we can see PowerMill 2021.0 on the left and PowerMill 2022.1 on the right. And you can see that we've taken this toolpath and we're sketching a polygon to define a region of toolpath that we wish to preserve. Once both regions are defined in both versions of PowerMill, we simply click Apply. You can see us clicking the Apply shortly to start the command. Now, we've started PowerMill 2021 first to give it a bit of a head start, and then we click Apply for PowerMill 2022.1. Note at the bottom of the screen the text Scanning Model is appearing to tell us that PowerMill is in the middle of preparing the model data. What's very interesting is to see that PowerMill 2022.1 completes the command faster. It then applies the leads and links, and the form is closed down and the command is complete. And shortly thereafter, you can see PowerMill 2021 catches up, finishes its command. It is also complete, but it happened a little bit slower. Now, the results of that test on this large press tool die measuring 2000 millimeters in X, 1300 millimeters in Y, and 560 millimeters in Z is that we've saved 16% overall calculation time on this one task. And remember, this was taking a multi-pencil finishing toolpath that was been calculated to a very tight tolerance and limiting it to isolate a small region. So we've saved 16% of our calculation time on this one particular process, but don't forget we've seen bigger time savings in other data sets, and you may see bigger time savings too using your own data on your own PC. Okay, still talking about toolpath editing, I'd like to talk about some improvements that we've put into PowerMill's toolpath limiting functionality. Now, as we've just seen, the ability to limit a toolpath is arguably one of PowerMill's most powerful features, and it's certainly one that I know many of you use on a regular basis. Now, with the release of PowerMill 2022.1, we've introduced two small but significant improvements to usability. The first is the introduction of a new rubber band preview, and you can see this appearing on screen now. As we click the points to define the polygon we wish to use for limiting, my cursor has a rubber band preview attached to it. This helps me to visualize the areas of the toolpath that we will be limiting, either to preserve or remove. Now, the second improvement we've put into PowerMill for toolpath limiting is a new Restore View button. You can see that we've accidentally rotated the view out of the orientation that we had at the start of the command. Returning that view to its original setting would be difficult, possibly very, very challenging, maybe even impossible. But the new Restore View button, as the name suggests, simply resets the view back the way it was, allowing me to continue my command, saving me time, saving me hard work and effort. So collectively, these two improvements will have an impact on your general day-to-day user experience of toolpath limiting. The next thing I'd like to talk about today is some improvements that we've put into PowerMill specifically for macro security. Now, I hope many of you are using macros today. PowerMill 2022.1 now runs additional security checks whenever you run a macro inside PowerMill to identify any commands that we feel could be hazardous, not just to your use of PowerMill, but to the security of your data outside of the PowerMill interface. Now, you can see a preview of this interface on the right hand side of the screen. Effectively, we have run a macro even, my mistake, and PowerMill has looked at that macro and identified that it's got commands that are hazardous. And it presents three options. Either we can trust the macro and allow it to run, we can don't trust it, so the macro will be blocked, or we can inspect the macro to check its contents line by line. So what sort of hazardous commands are we actually looking to trap here? Now, these are commands such as the 5 that are listed on screen that go outside of the PowerMill interface and interact with the data on your local computer or even your broader network. Commands like opening a file and writing data to it. Commands like making a directory on your network folder, or possibly even commands like running another application such as Excel and interacting with it. The point is, these commands could be a potential loophole to allow you to expose vulnerabilities to the data in your network. And so now these security checks will give you a greater confidence that you're protecting your data. Now, you can choose to approve and trust macros one by one each time you run them, or alternatively, you can predefine a folder containing multiple macros and they will all be trusted in one command, saving you yet more time. Now, moving on, for a number of years, PowerMill has provided specialized capabilities for those of you driving additive manufacturing processes, such as directed energy deposition, or DED, or even fused filament fabrication, FFF. Now, with the release of PowerMill 2022.0 earlier this year, we introduced a feature to drive toolpath efficiency whereby the profile and raster infill toolpath segments could be combined together into a single, safe and efficient toolpath type. But at that point in time, this could only be used in cases where your base surface was planar or cylindrical. PowerMill 2022.1 builds on this and now allows you to build features using that same combined profile and raster infill toolpath on any base shape. So that now includes general surfaces of revolution or indeed any arbitrary form. Now, this greatly increases your choice of CAM programming and should allow you to result in your ability to create highly efficient toolpaths that can produce a much greater range of parts. Now, the second improvement relates to tool axis controls when building parts with profiling toolpaths. It's a difficult thing for me to explain. It's much easier to show you a video. So let's start that video now. Now you can see here we've generated a toolpath that's profiling around a form, but because the form contains overhanging geometry, it would be better for us if we can deposit that form with the tool axis aligned to point the material directly onto the previous layer of material that was deposited beforehand. So that's the improvement that we've included. You're now able to derive the tool axis of your DED toolpaths such that they deposit material more effectively based on the previous slices. What's the impact of these two improvements? Well, it allows you to produce more efficient strategies that deposit material in a more efficient way. Clearly, it allows you to produce more complex geometries, such as parts with overhanging forms, and ultimately allows you to produce better quality additive manufactured parts. Now, moving on, the next feature we're going to touch on here relates to better machine motion when using orientation vectors. Now, some of you may not be using orientation vectors, and so this will be completely new to you. Those of you that are using orientation vectors, I hope you're going to see a positive benefit from this latest update. Either way, let's cover what orientation vectors are and how this improvement benefits you. Well, when creating toolpaths for use on multi-axis machines, orientation vectors can optionally be used to control the way the rotary axes behave. Now, this is especially useful in cases where the machine could choose multiple configurations or solutions to achieve the same machine position. Think about driving an industrial robot. It could be that the robot itself can orientate its various different members in different ways and yet still position the tool at the same point in space with the same tool axis relative to the workpiece. But this is also applicable on a standard 5-axis machine with a table-table configuration. The table of the machine could rotate away from the operator or towards the operator, and just by spinning the C-axis one way or the other, you can still achieve the same tool relative to the workpiece. Now, both of those are valid solutions, but the chances are you would rather choose one, maybe to make it easier for the operator to see the workpiece, certainly not leave it to chance. And so it's here where orientation vectors can help. PowerMill allows additional vector information to be applied to the individual toolpath points, and this information can be used to better control the machine's rotary axes, both in a simulation, but also when you post-process the NC code. Now, for some time, PowerMill has provided the ability to simulate a toolpath using a digital twin of your machine tool, and crucially, for the simulation itself to modify the toolpath to update the orientation vectors that are used. Now, this is achieved by activating the Use Simulated Orientations option that is available in the Toolpath Editing section of the PowerMill ribbon. You activate these options, simulate the toolpath, and what you see in the simulation will be what is exported and post-processed to your CNC machine tool. So it's a what you see is what you get approach. This latest release of PowerMill 2022.1 includes enhancements that improve the consistency of the orientation vectors that are calculated during the simulation part of this process. And if you're using orientation vectors, you should see a noticeable improvement in the motion of the machine with less erratic motion in situations where the toolpath passes through an axis singularity. So as well as improving the motion of the virtual machine simulation, the improved orientation vectors will be transferred out, resulting in better quality motion after post-processing for your CNC machine tool. Now, it's easier to see this with a visual example. So here, we're simulating a small section of a 5-axis toolpath that's machining a customer part. Now, it's worth noting we've removed the CAD model on purpose just because we've signed a non-disclosure agreement with this customer and we don't want to break that agreement. Now, for various reasons, the shape of the model, the position of the model on the machine tool, we can see that the toolpath contains orientations that get very close to an axis singularity. That's where the Z-axis of the machine is very close to being coaxially aligned with the C-axis of the machine. And that can result in sudden erratic movements of the C-axis. And we can see that on the left-hand side of the screen if we look at PowerMill 2022.0, notice how the toolpath is flipping the C-axis on multiple occasions. Look very carefully at the C range highlighted by the red box, and you can see we're transitioning from minus 90 degrees to 0 degrees to plus 90 degrees, back to 0 degrees, minus 90 degrees, and so on. So the C-axis is flipping positive, negative, positive, negative. Now compare that on the right-hand side of the screen with PowerMill 2022.1, we can see the range of movement on the C-axis is much smaller. Once the machine positions the C-axis into the plus 90 degrees orientation, it stays there. So the C-axis is no longer flipping from side to side. And we can see that even more clearly if we look at a plot of the individual axis motion. If we display the plot for the C-axis in PowerMill 2022.0, and you can see the C-axis is this blue-purple line, notice how the line goes from 0 degrees to plus 90, to 0 degrees to minus 90, to 0 degrees to plus 90. It's up and down and up and down. Whereas, if we look at the whole toolpath in PowerMill 2022.1, you could see that the machine goes from 0 degrees to 90 degrees and then stays in that 90 degree zone. So there's much less movement of the C-axis of the machine, and the impact here is clear to see. Less movement of the machine results in a faster machining cycle time because the machine doesn't have to move so much. There could be an improvement in surface finish. There's also going to be a small improvement in the long-term maintenance cost of your machine because you're using the C-axis more effectively. Now, this last feature that we're going to talk about today is one that I'm particularly excited about because it relates to a completely new toolpath type, specifically aimed at improving the way we machine rest material. Now, before we go too far, it's important to stress that this feature is being released in preview mode. It is not a fully released feature yet. So remember that safe harbor statement that I mentioned earlier. Now, even so, we believe the functionality has reached a point where it is usable, and we wanted to reveal it to you through preview so that you can start to use it yourself. And hopefully, provide feedback to Autodesk through the usual ways, so the user forum, so that we can then work on this algorithm to make it better and release it in the very, very near future. So let's just take a step back. What do we mean by rest material? Well, in simple terms, this is material that's left unmachined on parts simply because we've used larger cutting tools or roughing strategies that were unable to fully machine the entire component. So think about the bottoms of pockets and the material that will be left in those pockets by large cutting tools. Now, PowerMill provides multiple different ways of machining this rest material. Strategies like pencil finishing, multi-pencil finishing, corner finishing, and even the use of rest boundaries all aim to help find and remove this rest material safely and efficiently. Now, while these strategies have their own strengths, they also have their weaknesses, and there may be cases where material is left unmachined by one strategy and you'd need to go and remove it using another, and that's clearly not ideal. And so with this in mind, PowerMill 2022.1 includes a completely new strategy called rest finishing that combines the best bits of rest boundaries with the best bits of pencil and corner finishing toolpaths. Rest boundaries are great at identifying the unmachined stock. That's their strength. Corner and pencil finishing toolpaths are great at creating effective toolpaths that flow in steep areas and shallow areas to effectively remove material. Our goal in this new strategy is to combine the strengths together into one unified solution that allows you to accurately identify and remove this material safely and efficiently. And we can see some examples of this in this toolpath that's on screen now. Note the quality of the toolpath in terms of the extensive machining. We've identified all of the material that needs to be removed. Notice also the shape of the toolpath segments. See how it's flowing in steep areas and it's flowing in shallow areas in a very different way. So it's a safe and efficient way to remove that stock. And as you would expect, this toolpath will be configurable using a variety of different settings with independent controls over the behavior in steep and shallow regions. This new rest finishing strategy has already been tested in our beta program for quite some time, and we've reached a point where we really feel confident that the strategy is usable, and so we encourage you to use it and provide feedback to us through the user forum. And once we're happy with the quality and we've improved the code even further, we'll be excited to release it in the very near future. So, just to summarize, this latest release of PowerMill sees multiple improvements to help you get more from your 3 and 5 axis CNC machines and cutting tools, including the ability to background process NC program and toolpath verification, improved controls over projection finishing toolpaths, faster toolpath settings forms, faster model preparation for toolpath editing, improved usability for toolpath limiting, and that really exciting new rest finishing toolpath that we showed you on preview. But it doesn't end there. There's more improvements inside Power than just those 6 or 7 features. So in addition to these major highlights, we've also included a host of fixes and other smaller but equally important improvements that all have a positive impact on performance and reliability. So PowerMill 2022.1 is better because it provides new post-processing options to now display all valid option file types within the post-processor interface and not just those files with the .opt extension. PowerMill is better because it includes updated user documentation, specifically covering some of the more advanced elements of PowerMill, like orientation vectors, some of those things we were talking about earlier today. PowerMill is also better at detecting and processing badly trimmed surfaces. Now, if you've ever imported a CAD model from another supplier and it contains small or poorly trimmed surfaces, PowerMill can find those problematic and it can result in error commands appearing and toolpaths failing to calculate. PowerMill 2022.1 now includes a far more robust algorithm to better handle and process these problematic surfaces. Now, this should improve the robustness when importing CAD models, but also you'll see a reduced likelihood of error messages occurring when toolpaths can't be processed. Now, not only is PowerMill better, but it is faster. We've already seen some examples of that today with faster toolpath settings form, faster model preparation, but we've also sped up the spun profile calculation time, specifically for the creation of turning toolpaths, just because we've multi-threaded this function, and now in our test we're seeing up to 30% faster calculation times. So PowerMill is faster, it's better, but it's also safer. It's safer because of those improved security options when running macros. We've also improved the safety of our link calculation. So now calculation of non-gouging links involving the shank and holder are considered, and it is now possible to provide a non-colliding link and a non-gouging link. In previous cases, it may have been possible that the absence of a non-colliding link would result in PowerMill producing a gouging link by mistake. This has been improved. And also, we've improved the safety of point distribution in PowerMill. So in cases where a toolpath uses point distribution, but a safe link cannot be calculated, PowerMill would previously apply the default link type, which may mean it didn't apply the requested point distribution options. Now, with this latest release, PowerMill correctly applies the correct point distribution values to all links, including default links. So you can see this release of PowerMill includes a whole host of improvements that really will impact your day-to-day quality of life with using the PowerMill product. So we're nearly at the end of our time together. What could you do if you'd like to learn more about this specific release? Well, there's a few things you can do. First of all, you can visit the official online help site where you can learn more, access in-depth tutorials, read about worked examples, maybe even access related learning content, not just for this release, but for previous releases too. You can also watch an on-demand webinar where I dig into the specifics of this particular release. In fact, it's this webinar that you're watching today. And finally, if you want to watch some step-by-step tutorials on how you can use these new features yourself, then head over to YouTube, search for PowerMill What's New, or even just click on our bit.ly link that you can see on screen here, and you'll be able to watch those videos at your leisure. What if you actually want to download this latest release? Well, the answer very much depends on whether you're an existing customer or not. If you are an existing customer, you should start to receive the latest updates automatically starting the 8th of November. And this happens in one of two ways. Either you'll use the Autodesk desktop app that you see in the bottom right hand corner of your screen in the task tray, or you can log on to your Autodesk account at manage.autodesk.com. Once there, you'll see a list of products that you're eligible to receive. Simply select the product of interest, download it, install it, and you're good to go. But what if you're new to PowerMill and you'd like to learn more about its capabilities? Well, you can visit the PowerMill Product Center on autodesk.com/PowerMill, and here you can watch handy videos to learn about PowerMill's capabilities, its features, as well as reading stories about our customers and how they're using PowerMill to transform their business to be more successful. You can also connect with our team of manufacturing specialists and take advantage of a free, no obligations evaluation of PowerMill for your business needs. We can review your biggest challenges and headaches, then identify the best Autodesk solution for you, including the option to access short and long-term free software evaluations where you get to use PowerMill for yourself using your data. And with that, our time together is at an end. So I would say thank you very much for your time. I hope that you found this very informative. I encourage you to download that latest version of PowerMill and start benefiting from these improvements yourself. And with that, I'll bid you farewell and have a great day.